All right. First thing we covered in this unit, very first day, we went over history and structure of the atom. Okay. I'm not going to be asking you what year did this happen or things like that, because I don't care about that level of detail, and that's just trivia. Okay. However, I would know the names of like important people. All right. I would say important people would be like Dalton. Okay, as he came up with the whole idea. Okay. Incidentally, I would also know probably Dalton's 4 points, as they may be important in terms of like explaining things. Okay, there may be some written response items where you're asked to do some explaining, and you can almost always work anything back in chemistry back to Dalton's 4 points in his atomic theory. Okay, I mean, we made it part of our hypothesis in the reactions lab about atoms being separated, joined, or rearranged. Okay, so there's always some way to work that in, and of course there could be a multiple choice question. You know, which of the following is not one of Dalton's 4 points? Okay, something like that. That's mostly going to be recall. Okay, the stuff that's in there. Okay, so like knowledge, multiple choice kind of questions. Okay, something like that. The other, I think, really important person would be Rutherford. Okay, because he's the one who proved the nuclear model of the atom, and that's obviously pretty important. Okay, I would also know the models well enough to recognize a picture of one. Okay, like if I have a multiple choice question and I have a picture of one of the models, I would say which model is this? And you would have to say, oh, that's, you know, that's the Rutherford model, or that's the Bohr model, or that's the electron cloud model, or whatever. Okay, so just make sure that you can recognize those from a picture, and the picture is pretty obvious. Okay, and then obviously know the parts of the atom and where they are. Okay. And most importantly, from this lesson, second most important thing, because Dalton's 4 points are the most important. Okay, but the second most important thing, because I'm going to ask you to do this. I'm going to ask you to draw an atom. Okay, and what I mean by draw an atom is I'm going to give you a specific element. I want to see what that atom would look like according to our current understanding. Okay. Our current understanding of what the atom looks like, I need a picture of that atom in particular, which means you need to be able to figure out how many of every particle it would have in it in order to draw it correctly. You will have your periodic tables, yes. No, I'm giving you quite a bit already. I'm not going to draw the answer on the board. No. Okay, I'm giving you quite a bit already. Okay, so that's what you need to be able to do. All right. Naming and formulas. Okay, obviously you have to be able to do that. You can't do reaction stuff without it. Okay, you can't do the mole equation calculations without it. You got to be able to write names and formulate properly, right? There will be some multiple choice. Which of the following is the proper formula for nickel 2 bromide, or which of the following is the proper name for NiBr3? Okay, or whatever, something like that. There'll be a couple of multiple choice questions just about naming and formula. Okay. The rest of it, it's a base skill for the other things you're going to be asked to do on the test. Okay, so definitely make sure that you can do that. Okay. Third thing. Properties of compounds. Okay, there could be some multiple choice questions about, you know, you have an unknown compound and here are its properties. Is it ionic or molecular? Or here's a couple of possible identities. Which one might it be? Okay, so I mean, it would be something like obvious, like you have a blue crystalline solid that conducts electricity and is neutral in pH. Okay, it's you know, carbon dioxide, oxygen, mercury, or copper 2 sulfate. Okay, like it would be like obvious kind of things, right? We know that blue things are all blue crystalline solids usually contain copper. You'll need to go over lesson 4 essentially. Okay, just reviewing those kinds of things. But we did do that in the lab, so it's still something I need you to be able to show to me that you can still do. All right, so that would probably again be multiple choice type stuff. Solubility and the polar nature of water. There will be some questions that will ask you to use your solubility chart. Okay, like I'll give you a reaction and I'll say, which of the products is not soluble? Which is exactly what you were asked to do in question number 2 in the analysis of your reactions lab report. Okay, I would give you a question just like that. Okay, you look at the products, you look them up on the solubility chart, and you tell me whether they're soluble or not. Okay. And then about polar nature of water, okay, we need to understand what it means to be a polar molecule. You've got to be able to explain what this means to me. Okay, be able to explain what the polar molecule is, okay, about that uneven distribution of electrons, one end's positive, one end's negative, okay, how that makes all these other behaviors that we talked about, cohesion, adhesion, right, surface tension, right, all that kind of stuff, okay? Make sure you go over your notes on that. There is a written response question where you need to do some explaining about how water behaves and why. Okay, and there's also a couple of multiple choice questions on terminology related to solubility. Okay, you got to know what a solute is and a solvent is because I'm going to use those terms, okay, on the test. So if you haven't become familiar with those terms, the question won't make sense when you get to it. Okay, 5th thing. Scientific methods, experiment design. What I mean by that is I give you a question that has an experiment in it, and I ask you, in this experiment, what's the manipulated variable? In this experiment, what's the responding variable? Okay, so you need to be able to read an experiment and go, okay, here's what seems like they're doing. So this would be manipulated, this would be responding, this would be controlled. Okay, you've got to be able to do that from a given experiment. Okay, that would also be in the multiple choice. Okay, anything that you're asked to explain, is that going to be in the multiple choice? No, if it's explain or demonstrate, okay, it's probably a written response item. Okay, so far what we've just been going over here is going to be, it's just knowledge and recall kind of stuff, except for the explaining the polar nature of water part here. Okay, and then sorry, solubility. I forgot something about solubility. In the written response, there will be an application question. About solubility. Okay. That question will involve a real-world situation. You will have to find a way to solve a real-world problem using what you know about solubility. Okay, that would be like the use of your solubility chart, possibly reaction types, okay, that could involve changes in solubility. Okay? Really only one reaction type ever really involves the change in the solubility of a substance. Okay? That's as much as I'm going to tell you because I want that question to be a adequate or a real evaluation of how well you can think outside the box. There's one of those on basically every exam. Okay? Kind of the wheat from the chaff kind of a question. Okay? That's going to be it, and it's on solubility. Okay. Sixth thing. Now we're into reactions. Okay. This is, I mean, there's a little bit of stuff in the multiple choice, but mostly this is what the written response is. Okay? The written response is you demonstrating your skills. Okay? And those skills are balancing, writing, and that would be words and formula, just like our quizzes, and just like your assignment, and then predicting as well. Okay? If there's one thing that's worth more marks than any other thing on that test, it's that. The whole test set of 84 marks, 25 of them are on reactions. Okay? Give you an idea of weighting. Okay? 25 marks are directly about your skills to do with chemical reactions out of 84. Okay? So like close to a third. Okay. So if there's one thing you're going to spend more time studying, practicing in preparation for Wednesday, it had best be that. Last thing is mole calculations. Okay, I know we just started that the other day. Okay, we still have Monday and Tuesday to work on that. Okay? And I think I will likely have time to go over a few more mole examples today. Yeah, kind of was my plan. If you guys didn't have a lot of questions, I would go over a few more. No, it's just on Wednesday. Okay, so make sure you're able to do those. Obviously, like I said, we haven't spent a lot of time on that yet, but we are on Monday and Tuesday. All of class Monday and Tuesday is going to be working on the mole equation stuff, so we get really practiced up at it. And okay, remember, there's only 4 ways that I can ask a mole equation question. Okay, and I'm asking 3 of them, so it's 12 marks. Okay? I think it's 12 or 13 marks on that. Okay, so that's the key stuff. I'm not saying that there aren't other little things here or there, like a 1-mark multiple choice question on something else that I've maybe forgotten or not listed here. Okay, but this is the big stuff. Okay, these are the things you want to concentrate your efforts on. Okay. Now, the test has 33 multiple choice questions. So 33 marks are the multiple choice. Okay, that means 51 of the marks are in the written response. Which part should you do first? Do the written response first, okay? If you get pressed for time, and you shouldn't, but if you do, okay? Understand you don't get to come back and finish the test later, okay? Once you leave the room, the test is over, okay? Because I can't control who you talk to and what kind of questions you ask, okay? You got to get it done in the class time provided, okay? If you get pressed for time, it's easier to rush multiple choice questions than it is a 6-mark explain this concept kind of question in the written response. Okay? It's better to get those done since there's more marks there anyway. Okay? It's best to get the written response done first and then move on to the multiple choice, because multiple choice tends to go pretty quickly. Awesome. You have the entire class period to do it. Okay? As I will have the tests handed out to you right away, and you can get to work on it. All right. Everybody with me on that? Okay. In terms of test taking strategy, this can be your, probably one of your first high school exams, obviously your first high school science test. A couple of tips. Don't stall. Okay, and what I mean by stalling is, I don't know the answer to this question. I'm going to sit here and stare at this one question worth 1 mark for 10 minutes and get nothing else accomplished. Okay, that is the single biggest thing, biggest mistake that people make on tests, is to sit and focus on something they can't do. All right, first off, it wastes time. Secondly, it sets you into a defeatist mindset. Okay, that means you just start thinking you can't do anything, and that's not true. Okay, and that's not the mindset you want to have on a test. You want to come into a test thinking you know everything. Well, maybe not quite that far, but okay, like a certain amount of nervousness / confidence is always a good combination to come into a test with. Okay, but you need to not stall on a question. Honestly, guys, if you don't know what to do on a question within 20 seconds of having read it, move on to another one. Come back to it after. It'll still be there, and there might have been something else in the test that jogs your memory about it. Okay, but if you just sit there and stare at it, you're going to accomplish nothing, and you're going to get behind the 8 ball in terms of time. Okay, so if you don't know the answer or you don't know what to do within 20 seconds of reading a question, move on to another one. Come back to it. Okay, that is the single biggest piece of advice I can give you, right? Because I see it happen all the time, and it's just sad. Okay, because then you don't get finished the stuff you knew how to do. Okay, that's the really sad part, is that question gets left blank that you knew how to do because you didn't have time to do it. Okay, and in fact, do you need to do the test in order? No. Okay, it's always a good idea to read through the test and go, all right, what I always do is I star the questions I know I can do real quick and real well. Okay, and I do them first. Okay, no matter if they're the last question on the test or the first question on the test, I do the ones I'm confident in first, because then I feel good about myself and I go into the other ones with a little more confidence. Okay, with the exception of my Organic Chemistry 201 final, which I read through 30 questions. I knew how to do 4 of them. I did those 4, and then I kind of struggled through for the next 2.5 hours. I think by the end I was done about 16 questions, sort of. Yeah. The curve is a beautiful thing when you're graded on the curve, okay? Because I got like 39% on that exam, but I passed because I did better than 50% of the people did. Because the class average was 36. Yeah, surfing the curve. That's triumph for you. That's not how you want to get. That's not how you want to be successful. Okay? That's why I'm not a chem teacher. Okay. So other things to think about. Obviously, you need a calculator for this test. So make sure that you have a calculator. Cannot be your phone. Okay. I'm going to put all your phones in a bin. I'm going to come around with a little Rubbermaid bin and collect your phones, okay, before the test. So make sure that you have a real calculator. You must also have pencil for the multiple choice. Okay, I'm using a new scoring app to score the multiple choice, and you must erase your mistakes completely. Okay, if you have, like, this is what I see all the time, and it just enrages me. So you got your 4 bubbles, right? And you're like, oh, it's this one. No, it's not. It's this one. No, no, no. Oh, okay. Erase them. Don't do it in pen. Okay, do it in pencil and erase them completely. Because I actually have people. I mean, yes, people who use pen have to do this. I have people who use pencil do this. It's like, erase it. Okay, because guys, if you have more than one thing checked or filled in on that row, it'll just get marked wrong. Okay, like the scoring app will just mark it wrong. Right. So make sure that you only have one answer selected and the others are completely erased. Okay. So pencil, calculator, got to have those 2 things. It would be advisable to bring your periodic table, but if you forget yours, I have extras and I can supply you with one. Okay. I am also going to come around and look at your periodic table. Okay, just to make sure that it doesn't have a lot of stuff written on it that it maybe shouldn't have. Okay, so if you were just thinking to yourself, oh, I'm just going to write all the stuff down on my periodic table, I'm going to look at your periodic table. Okay, if it looks like my notes package in condensed form, I'm going to give you a new periodic table. Okay, and not that I think any of you would do that, but I've had a person try that once. Okay, so just know that I will check that as well. Okay, do you guys have any questions, or is there anything you want me to go over from this unit? Awesome. Yes, to find the number of neutrons, you take the atomic mass and you subtract the atomic number. Yeah, so like if it was sodium, it would be 22.99 minus 11. And then obviously round. You need to have a whole number of electrons, or sorry, neutrons. You can't have a partial neutron. Yeah. Okay, anything else? Here we go. Yes, part of that is indicating to me the proper number. That's why I'm giving you a specific element. You need to draw that atom with the right numbers of all the particles. Yeah.
When you're looking for the drawing, like, how do you want it drawn?
I want it to look like our current understanding of the atom.
So, like, so you kind of do like that circle thing, you know, like circles in the middle, like,
You're asking me to give you. I've given you a lot already. I'm just. Yeah. I'm not going to outright say what I want. Okay. I've already told you the question. I'm not going to tell you the answer. Okay. All right. Any other questions? Okay, what you just received is the review package. As you can see, there's a little bit of stuff in there that gives you suggested activities. There's a little bit of stuff in there that is like, here's some review questions, and then there's the practice test. Okay, so you can see there's what, about 25, I think I put on 25 multiple choice, and then there's 6 written response. Okay. Those are all, in fact, that is an old unit exam, minus about 2 questions. Okay, so that gives you a good idea of how I'm going to word things, the kinds of things I'm going to ask, the level of difficulty that I'm going to ask. Okay, your test is going to look pretty much like that. Obviously not exactly the same questions, okay, but it is going to look just like that. It's going to have some multiple choice, and then it's going to have those kinds of written response questions. Okay, I kind of operate off of a skeleton. Okay, they have my exams all have a skeleton. That's you've got it. You've got the skeleton. Okay, what's going to be different is the muscles. Okay. All right. The key for that practice test and for that review package. Okay, I will post on Google Classroom today. Okay, but you can also find it on my website if you go to Science 10 stuff, and then you go into chemistry. Okay, it's right down here. It's the very last file in the chemistry unit. Science 10, chemistry, unit exam review key. Okay, I'll just post that file on Google Classroom today, but if for some reason you can't access it, that's where it is. Okay, on the website you can access it there, and it's basically just that with the multiple choice answers are highlighted in green, okay, and the other ones are just written in as numbers or whatever. Okay, questions on that? All right, I think we have time to go over some mole equation stuff then. Okay, so I probably want to write these down. Okay, I'm going to give you another 4. Okay, examples of the only 4 ways I can ask a mole equation question. Okay, we'll start out again with the most simple. How many moles of calcium carbonate are in 125 grams? And again, reminder, on a unit exam, I won't give you that formula. I will write the words calcium carbonate on there, and you'll have to come up with that formula on your own. Okay, so what do they give me in this question? They give me the mass, right? So they give me little m is 125 grams. And what else do they give me? They give me the substance, okay? And it would be really hard to solve a mole equation question without that piece of information. I've never seen one that doesn't have that, okay? So molar mass, calcium, carbonate. So we'll have our 40.08 for calcium. Okay, plus how many carbons? 1, so that's 12.01. Okay, plus 3 oxygens. All right, so we got our 40.08 plus 12.01 plus 48. Okay, so 100.09 grams per mole. All right, they're asking how many moles, so I'm looking for N, which is perfect because I have the other two pieces of the mole equation right now. I have little m and I have big M. So all I have to do is plug in my numbers. 125 grams divided by 100.09 grams per mole. All right, gives me 1.25 moles. Okay, so that would be like a 3-mark question. Okay, you get 1 for givens and molar mass, 1 for plugging in the numbers because you don't have to do any manipulating, and 1 for the answer. Yes, Avogadro's number is on the front of the test. Yep. In here? No, I don't care whether you have the units in this part of it or not. Make sure you do have them in your givens, though. So oftentimes I see people mix up numbers, and it's because they don't have units on them. Usually when people write the units, like grams and mass, okay, that goes together. Moles and N go together, right? Okay, anyone need that one anymore? All right. Second way I can ask you a mole equation question is I give you the number of moles and ask you to calculate the mass. So in this question, they gave me N, the number of moles, 2.7 mole. Okay, and again, they told me the material and they gave me the formula, which again, I wouldn't do. Okay, Li3P. So lithium is 6.94, and there are 3 of them, and phosphorus is 30.96 or 97? 97. Okay, and there's only 1 of it. All right, 6.94 times 3 plus 30.97. All right, 51.79 grams per mole. Okay, I now have N and big M. The question asked me to find the mass. So N equals little m over big M. If I want to get little m by itself, I've got to move big M. I'm dividing by big M right now, so to move it, I do the opposite. What I do to one side, I do to the other, and I've solved now for little m. Now I can plug in my numbers. So little m is going to be 51.79, my molar mass, multiplied by 2.7 moles. All right, 139.83. What are my units? Right. Okay, so you get 1 mark for your answer, 1 mark for plugging in the numbers, 1 mark for the manipulation, and 1 mark for the givens. Okay, questions on that one? All right. How did I know I didn't need to use Avogadro's number in these first 2? Sydney? Right. It never asked for the number of molecules. It never gave me the number of molecules. That's the only time I'm going to need Avogadro's numbers. I'm either asked to find the number of molecules or the question gives me the number of molecules. Then Avogadro's number comes into play. If there's no mention of number of molecules, then you don't need Avogadro's number. Okay. Now, sometimes in a question it'll say, what is the mass of 2.7 moles of Li3P molecules? Don't get confused. Okay? It may have used the word molecules, but never gave you them, nor asked for how many there were. Okay, that's what you got to look for. Because sometimes the word molecules will be in there, but it's not asking for it, nor is it giving it to you. Okay, everybody follow the difference there? I think that threw people yesterday on the worksheet. Seemed anyway in some of my other classes. So. All right, how many molecules? All right, well this one outright says how many molecules. So we know in this one we've got to solve for how many molecules, and we're going to need this number. What is that number again? It's Avogadro's number, and what does it mean? Right, how many particles are in a mole? Okay, so we know the mass. They gave it to us, 230 grams. And they told us that this is iron 3 oxide. All right, so that's going to be 55.85 times 2 plus 16 times 3. All right, 159.7 grams per mole. All right, can I use Avogadro's number yet? No. Okay, I still need something else first. Avogadro's number tells me how many particles are in a mole. What do I not know yet? How many moles? Right, I got to figure that out first. Okay, so I'm looking for N. Okay, so N is going to be little m over big M. I don't have to manipulate it. That's 230 over 159.7. All right, it's 1.44 moles. All right, I now know how many moles I have, and I know how many molecules are in a mole. What do I do with those two numbers? Multiply them, exactly. Okay, so number of molecules equals N times Av's number. Okay, so in this case, that is going to mean 1.44 times 6.02 times 10 to the 23. 1.44 times, in brackets, 6.02 E23. All right, so we're looking at 8.67 times 10 to the 23 molecules. Always remember your units. If there's one that people forget to put units on, it's that one. Right, because then it would get confused with moles. Yeah. Yeah, it's annoying. You have to write out the whole word. Sorry about your luck. Okay. All right, so 1 mark for givens, 1 mark for calculating the number of moles, 1 mark for plugging in the numbers here for Avogadro's number, okay, and 1 mark for the final answer. So that would be a 4-mark question. Okay, anybody still need that one? Hey, another thing, guys, for Wednesday, whatever calculator you have, make sure that you have like used it before. Okay, like practice with it so you know how to put this part in, right? I mean, if you were stuck, I would come over and help you punch numbers into the calculator, but okay, hopefully you would already kind of be prepared and ready for that. All right, last one. You're given the number of molecules and asked to calculate their mass. Okay, so it's basically we're doing what we just did in reverse. So we know the number of molecules is 5.42 times 10 to the 21. And we know that this is nickel 2 nitrate. Okay, so Nickel is 58.69, and there's only one of them. How many nitrogens are there? 2. So 14.01 times 2. How many oxygens are there? 6. All right. Should you expect me to do something cruel like that and put a polyatomic ion with brackets on it in a mole equation question? Yes. Okay, good. You guys know me well. All right. 58.69 plus 28.02. That's our 2 nitrogens. Plus 16 times 6. All right, 182.71 grams per mole. Okay, if I want to calculate M, I need little n, or sorry, I need N and I need big M. Well, I have big M, but I don't have N. How can I use the number of molecules in Avogadro's number to get N? Divide the number of molecules by Avogadro's number. Okay, to find number of molecules, we multiplied. Okay, if we're given number of molecules and asked to find something else, we're going to have to divide. Okay, so to get N, we are going to take our number of molecules, divide by Av's number. Okay, so that will be 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. Do I have less than a mole here? Yes. Okay, and that's what, remember I was telling you, always make sure your answer makes sense. Okay, this is a thought process I go through every time I punch something into my calculator. I look at the numbers I have, and I kind of estimate what my number should be. Okay, right now I'm looking at that, and I know I should get a decimal. Possibly one with the first position being a 0. Okay, possibly. Right, so I'm getting myself an estimate of what's a reasonable number I should get after I punch this in case I punch it in wrong, because it happens. Okay, all right. So in brackets, 5.42 E21 divided by Avogadro's number, 6.02 E23. All right, it's actually got 2 zeros. Okay, I have less than 1/100th of a mole here. Okay, I have 9 thousandths of a mole. Right? So 0.009 moles. Okay, now I can use the mole equation because I have N and I have big M. So N equals little m over big M. And to get little m by itself, I'm going to multiply both sides by big M. Okay, so little m is going to be then 0.009, the number of moles, times the molar mass, 182.71. All right, I have 1.64 grams of this stuff. One mark for the answer. 1 mark for plugging the numbers. 1 mark for manipulating the mole equation. 1 mark for calculating the number of moles. 1 mark for your givens. That's a 5-mark problem. Questions on how that one worked? Okay? All right. You now have 2 examples of every way I can solve a mole equation problem recorded for you. If you need to see them again, you know where to find them. Okay? Any other questions about the unit exam before class is over? Okay. If you find over the weekend that you're struggling with something, come in and see me next week. Okay? Scheduled help and lunch Monday, Tuesday. Okay? That's what I'm here for. So come and bother me because you're not really bothering me. Okay? That's my job. So come in.